Determination of carbon dioxide in amine gas scrubbing solutions. This procedure is typically utilized for the analysis of amine solutions which are used to remove environmentally controlled emissions from flue gases. This method measures the amount of carbon dioxide, CO2, in the scrubbing solution. This result is used along with other analysis to determine the amine scrubbing solution's efficiency and remaining capacity. This method is similar to ASTM D513, Standard Test Method for Carbon Dioxide in Water, Method G, Coulometric Titration Method. We'll begin by providing an overview of our CM5017 coulometric detector. In the cell compartment, we have the connectors that will be used to connect the cell to the unit. The black is for the cathode compartment, while the red is for the anode. Below the connectors, we can find the light source. Across from the light source is the detector that will detect changes in cell transparency. The provided USB drive can be used to load sample information and save all data. Next, we'll be providing an overview of our CM5330 acidification unit. First, we have the pre-scrubber with KOH solution where the carrier gas will flow into. Notice the level in which the tube will need to be filled. The carrier gas then flows through the Teflon tubing into the upper finger of the 3-finger adapter, down the condenser, and into the sample tube. From there, the carrier gas flows back up the sample column assembly, out of the lower finger of the 3-finger adapter, and via Teflon tubing to the post scrubber. Notice the level in which the scrubber will need to be filled. The carrier gas will then flow out to the cell of the coulometer. The acid dispenser used to pump acid for sample acidification can be placed in the compartment like so. The acid dispenser can pump adjustable volumes of acid. For our purposes, we will be using 10 mL of acid. The CM210-017 auxiliary scrubber consists of 2 parts. The bottom is a 100 ml sample flask like the ones used on the acidification model. The top is an adapter that allows the gas that is bubbling through the solution to exit. This is shown in the figure. Place the cell into the cell compartment of the coulometer. Before connecting, check that the cell current switch is in the off position. While the switch is off, connect the cathode using the black connector and the anode using the red connector. Then place the inlet tube through the holder on the right side in this case. Note that holders can be moved to the left if the acidification is placed on that side. And place the outlet tube through the holder as well. Now the cell is ready to be titrated. To connect the coulometer and the acidification unit, connect the inlet tubing of the cell to the acidification unit with the tubing coming out of the post scrubber. The check valve ensures that the carrier gas moves in one direction toward the cell. Once the cell is placed in the coulometer and connected, the cell current button is still in the off position, the acidification unit is working and the carrier gas is going through the cell, you can go to Run Cell Setup. The system will use this number to determine 100% transparency. You can move the cell slightly left or right to maximize this number. The number should be between 2,700 and 4,000 and stable within 10 digits. At this time, it is best to leave the system 5 to 10 minutes to stabilize. When the difference is less than 10 digits, press Next. The system will regard the final number as 100% transparency. Press Start Analysis. In this step, we'll titrate the cell down. The cell should be at 100% transparency and the cell current should be at 0. Flip the cell current switch to the on position. The cell current should change to 200 milliamps and the transparency should begin to decrease. The cathode solution will slowly change color and become bluer. The percent T should decrease to 29.5% plus or minus 0.1. When it does, the titration is complete. While waiting for the transparency to decrease, we recommend leaving the coulometer 45 minutes to an hour, even though 29.5 will be reached relatively quickly. This leaves enough time for the system to stabilize. After waiting for this period, the cathode compartment contents should be blue. Percent T should be 29.5, and the system is stable and ready. After that, press Next. Here, we can enter how many samples we want to measure. Be sure to include the blank measurement in your number of samples. You can enter all of the samples and their information now, or you can enter them one by one. To enter one by one, enter the first sample and press Next to enter the next sample. Remember to always start with a blank sample by typing in blank or selecting blank at the bottom. Determine the background rate of the system by measuring blank on the CM5017 carbon coulometer. Now the system is ready to begin analysis. To start the measurement of a solid sample, press Begin Analysis and pump acid into the sample column assembly. Displayed here, we have sample name, percent T, cell current, total amount of carbon in micrograms measured, and the elapsed time. There is also a button to abort sample. All the measurements will be listed in the fields here. When we press Begin Analysis on the display, it's time to pump the acid. Slowly pump 10 mL of acid into the system. You should see that the acid enters the system and the carrier gas begins bubbling through the acid. The sample column assembly can be lowered into the heating block if you want to use heat to assist CO2 release. We set the system to do 8 readings, which should take 7 minutes because the first reading is at time 0. Assuming that the system is clean and that high purity water and acid are used, blank rates as low as 1 to 2 mg of carbon in 10 minutes are typical. Normally, blanks lower than 1 mg of carbon per minute are accepted. If you are finished, press Done. If you would like to measure more samples, press Next. To change samples once the blank is finished, press Lift Up, unscrew the red joint connector, and slowly pull the flask down. Use a clean Kim wipe to wipe the tubing from any acid that might be left over on the outside. If you see bubbles of acid on the inside of the tubing, flip the tube a couple times to get rid of the bubbles. This sample was weighed in a Teflon cup and the cup is placed in the flask like so. Attach the flask to the sample column assembly with red joint connector and you're ready to start the next measurement. When the new flask is in place, press Next. Enter your sample name and size and press Enter. The weight of the sample is determined by the difference between the two measurements. Second, if the density of the sample is known, the injection volume can be noted and the weight can be calculated. This method requires a volumetric syringe. After a few samples are analyzed, the blank should be re-established and occasionally checked throughout the day. The sample flask does not need to be emptied until it is almost full. We can see that the percent T is slightly elevated because there is trapped CO2 from the air that was inside the flask. The system will purge that, and the percent T will go back to 29.5. When this is done, the cell current is 0 and the system is ready to begin analysis. To begin sample analysis, press Begin Analysis and pump acid into the sample column assembly. The system will measure until it reaches percent difference criteria and will then stop. At that point, you can press Lift and change the sample flask to put another sample in. When sample measurement is finished, you can see the results on the screen. If you have more than one sample, you can press Next and measure more samples, or if you are finished, you can press Done. The system will save these results on the USB. To measure liquid sample, we can start by entering a sample name and size. Screw on an empty flask with the red joint connector. To perform an analysis, draw the sample into a syringe that is fitted with an injection needle. Usually 250 to 500 microliters of sample is used, depending on the sample CO2 content. Note on sample integrity. Because of the ability of amine solutions to absorb CO2, sample handling is extremely important. The collection should be done so that the sample has as little contact with the air as possible. Ideally, the sample should be collected into bottles with septum tops. The septum tops allow the sample to be drawn into the injection syringe without opening the sample bottle. Click Begin Analysis. Start the carbon analyzer. Then, inject the sample into the sample flask through the septum at the top of the sample column adapter. Pierce the septum with the syringe so that the needle reaches below the second finger of the 3-finger adapter. Press down to release your sample. Be sure to wash the sample down with 10 ml of acid and to hold down on the syringe while dispensing your sample, or the pressure of the system will cause the plunger to be pushed up. When sample measurement is finished, you can see the results on the screen. The analysis accuracy is normally limited to the precision of the sample volume measurement. Typical overall accuracy is plus or minus 0.5 relative, with a titration accuracy of plus minus 0.15% relative. If you have more samples, you can press Next and measure more. Or, if you are finished, you can press Done, and the system will save these results on the USB. When you are finished with measurements or finished for the day, switch off the cell current, switch off the acidification unit, disconnect the acidification unit from the cell and coulometer, and then switch off the coulometer. Remove the cell and dump the solutions. Finally, clean the cell so it is ready for the next time you do measurements. Thank you for joining us for this demonstration of our CM140 unit from UIC Incorporate.